All right, students, so we've got question 13, a bunch of different combination sort of things. So the first one is, how many ways can the letters of the word harmonics be arranged? And what I'm just looking at here is if there are any repetitions of letters. I don't think so. I think every letter is unique. So I just need to count how many letters there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that means that there's 9 choices for the first letter, 8 choices remaining, 7, 6, 5. So that's just 9 factorial. If we had a word that did have repeated letters, um, like the word mom, for example, then we would take the 3 factorial ways of arranging all those letters and divide it by 2 factorial, because those are all the ways of um, arranging the repetitions there. If you had a word, I don't know why this word is on my head, but if you had a word like mommy instead, that's 5 different options, and then there's 3 repetitions of the letter M right there. If you had a word that had multiple repetitive letters, um, like race car, that has 7 total letters, but there are 2 R's, 2 A's, and 2 C's. So you just kind of go through and knock it down like that. So anyway, that's the first part. The second part asks about this. Okay, so the numbers that are bigger than 30,000, but also less than 9,999,999, so less than that, and divisible by 5, and only using the digits 0, 1, 2, 3, 5, 8, and 9. Okay, so let's go through the number of possibilities here. So we can have, how many digits are there? There's 1, 1, 2, 3, 1, 2, 3. Okay, so I'm going to consider numbers like if it's a big number, you can start it with leading zeros. So for example, it, I guess we have to break it down into cases. This is a little bit annoying of a problem, but we have to break it down into cases. So let's say that case 1. So we have here, let's say case 1 is that there's a 9 right there. Well, actually, that's not going to, it doesn't need to be a case because they have to be divisible by 5. So that's going to end up being okay. So let's see. I think we'll still have to break it down into cases. Okay, let's see. How many different numbers could we go here? We're using 1, 2, 3, 4, 5, 6, 7 different digits. Okay, so there are 7 options for the first one because it could be any of those numbers there. 7 options for the second one, 7 options for the third one, 7 options, 7 options, 7 options, and then just 2 options right there. The only other thing I need to worry about is this, and is greater than 30,000. So let's think here for a second. Maybe that's the right. Okay. So 30,000 is at this position right here. And so we need this one. Okay, so here's how we do it. Sorry, I'm kind of thinking through it as we go here. What I'm going to do first is do the case where these are non-zero. non-zero. And so if those are non-zero, then we're going to knock that down to 6 options for the first. Well, I guess we got to do it one at a time. Okay, so we could have, we'll do it in 2 different cases. So we'll just make this one non-zero first. So there's 6 options for that. Let me think. If this is non-zero here, if the first digit is non-zero, then there's, let's see. If the first digit is not zero, then it doesn't matter what that one is. So if the first digit is non-zero, then the other ones have those. So then case 2 is that the first digit is 0, one way of doing that. And so if the first digit is 0, then we're going to make the second digit non-zero. And then that makes this. And then case number 3 is that the first 2 digits are 0. So one way of getting each of those. And then I need it to be bigger than 30,000. So I only have these 4 options, 7, 7, 7, 2. And so what I'm going to do is multiply the 6s and the 7s and the 2s, multiply the 1s times the 6 times the 7s and the 2s, multiply all of those together, and then add up those 3 values to get there. So again, sorry, I was thinking through trying to see if there's an easier way to do it. I think you have to break it into 3 cases. Maybe you don't. There might be a better way. But case 1 is saying the first digit's non-zero because that's going to guarantee that it's bigger than 30,000. And then the second case is, okay, the second digit is non-zero, so that'll still be bigger than 30,000. Then the third case is that the first 2 digits are 0, and the third digit has to be bigger. So there we go. All right, last one on this is a committee of 5 from 7 men and 4 women. So 7 men, 4 women, choosing 5. Let's see. So that we need at least 1 male and 1 female, and there are more women than men on the committee. Okay, so we can do 11 choose 5 is all of the teams, so that's the total, minus the way of getting all men would be 7 choose 5, so that's all men. And then we need to make sure there are more women than men on the committee. So let's subtract the ways that there are 4 men and 1 woman, because we already did 5 men. Okay, so 4 men would be 7 choose 4, and 1 woman would be 4 choose 1. So that's a 4 man, 1 woman. Same idea here, minus 7 choose 3 times 4 choose 2, because that makes 3 men and then 2 women, and then all of the other committees would have all the requirements there. You could also, I guess, do it the other way, where you're saying that you have 7 choose 2 times 4 choose 3, because that's 2 men and 3 women, plus 7 choose 1 times 4 choose 4, and then these 2 answers here should be equal to each other. And if they are, then I did it right. Okay, so comment, ask questions if anything in there was confusing, and let me know if you think of a better way to do that second problem.